Hello everybody, my name is Berke Uçar and I'm a computer science student in Bilkent University. Today I will be performing my Physics 102 experiment which is called examination of energy loss on two capacitors for you. For a start, I want to introduce you with my instruments that I'll be using for this experiment. So first, I have a multimeter which is going to be used as a voltmeter. Three different couples of capacitors which have different values as couples. Three different resistors which have different resistances in order to obtain different circumstances, a power supply which we can adjust its voltage, and several cables as you can see. As a procedure, I will first adjust the power supply to 10 volts in order to charge the capacitor, and then by using the voltmeter, I will check if the capacitor is filling or not. After the capacitor is charged, I'll adjust other capacitor to the charged one in order to charge the uncharged one. By the help of the multimeter, which was used as voltmeter, I will observe the voltage, and then when it settles down, I'll note the voltage value in order to obtain and in order to calculate the total energy. And then I will compare the total energy first and compare the total energy last. Furthermore, I will conduct this experiment for different values of voltage, different values of capacitances, and different values of resistances between these two capacitors. One important thing here is settling down means observing the third digit after the dot for the voltage. Meaning that I will assume that the voltage is settled down when I see the third digit after the dot. So this third digit will be counted as error, cause and error ratio. The main aim of this experiment was to show that even though there are some resistances between these two capacitors, there will be no difference expected from the theory that they will get their half value as a total energy. With the help of the equations, it is expected that for each repeat of the mentioned procedure, energy loss of the system should be its half value. When the results are inspected, it can be seen that the slopes of the lines that represent data are almost zero, which is consistent with the expectation actually. When the deviations from the expectations are examined, there happens to be 1.5% error for collective data. Furthermore, there happens to be no specific difference based on theoretic behaviors of the capacitors on the error ratios when the proportions inspected individually. I have explained the systematic error causes while I was doing the experiment, so I'm moving on to the random error causes. Random error happened while I was attaching second capacitor to the first capacitor, which we can name as human error, and then happened throughout the experiment because of the instrument's conditions. So it can be named as random error too, since old capacitors or old resistances have impact on this experiment. As a learning outcome of this experiment, the theory holds with the practical issues. So we have obtained the half of the initial energy after we charge and discharge capacitors. So we can say that even though there are different circumstances happened, the energy's behavior will be the same.